Hi, my name is Amanda Walton and today I'll be showing you how to monitor vegetation over a period of time. Vegetation can be monitored in any landscape or terrain of any size or shape. The plots can be used in as little as a metre squared or a few hundred acres. There are many reasons for conducting this vegetation assessment. This includes measuring the effects of climate change and land use on the growth, mortality and functionality of above ground biomass over the length of a year. Before setting up your plot, you will need to have your establishment plan approved, train technicians for the role, then have them visit the site to make sure it is adequate for the assessment, and have the equipment assembled.
This is the equipment required for the process and the roles of those involved.
The placement of the plot must be randomly selected to allow fair trials to take place. On a smaller scale project, this could be easy as throwing a rock over your shoulder and using the landing point as the centre of your plot. On a larger scale, this can be done by generating random bearing points through one of the numerous programs available. To establish the plot, the technician must lay down two fixed-stringed baselines. Now, these baselines must be 90 degrees angle between them. Perpendicular lines made of a thinner string are going to be put perpendicular to these baselines, making even squares or subplots within them. So these are going to go along both of the baselines. The compass bearing for both of these baselines must be filled out on the plot establishment field form. This is done so any of the stakes that go missing can be replaced accurately.
First census will consist of measuring all trees in each subplot. Before this can take place, the measuring tape must be calibrated in case of stretching has occurred, and an error estimation must be measured. All trees being measured must be determined whether or not they are within the subplot. A tree such as this is said to be within a subplot if it is more than 50% inside the line. All stems greater than or equal to 10 centimetres wide have to be measured. Firstly, we'll have to measure 1.3 metres up the tree. So that's about there. Once 1.3 metres has been measured, we'll then make a sharpie mark on the tree. Once the sharpie mark is there, we'll get another measuring tape, a little more flexible than this one, and wrap it around the tree and take the measurement. Once that is done, we'll use paint to mark the point of measurement, or the POM. Once the POM is measured, we're able to put a tag, which is aluminium, to reduce the amount of stress to the tree. And that is about 1.6 metres up the tree. This is also used because if this mark isn't washed off at all, we are able to determine how far the POM was measured. The tree will then be marked with a unique number on an identification tag. This will be aluminium along with the nail, as it will cause least harm to the tree. In a separate visit, a sample collection may take place. This is done by taking a leaf or a sample from the tree and placing it in a clear plastic bag, which is then labelled for further identification. Site of your plot are required to provide you with a full reference of the vegetation in the plot area, and using this you're able to identify each tree in the subplot. 1 year after the first census, all stems must be remeasured. This must be conducted within the same 4 to 5 week period as the first census. Before beginning, the area estimation must be measured to ensure the percentage error is approximately the same, so there will be no major outliers. As explained for the first census, the tree must be measured, the POM marked, and the tree re-tagged. A recensus such as this is done to collate a numerical value that can be worked out and placed on the changes in the climate and land use that affect the plot's vegetation.
This method of vegetation monitoring has its strengths and weaknesses. The results will accurately show the percentage difference in the above ground biomass, the growth, mortality and functions of the individual tree. This will provide a figure to represent the effects on climate change and land use. Although there are many positives to this randomness of the plot, while making it a fair trial may also determine an area with little diversity, hence obtaining insufficient information. At a large scale, a slope may cause outliers as the vegetation differs between the progressions of the parts of the slope. Overall, this method for annually gathering information to evaluate the changes in vegetation is highly successful and has limited negative points.